Alright guys, today's topic is common wiring mistakes on outlets and switches in your home, office, or business. We'll start with the most common problem that I have seen or people talk about. Now that is putting the wires in the wrong location on the switches. Now you'll see here on this switch here, you've got a green terminal, a silver, and a brass or copper color. Pretty self-explanatory. Now let's go over it. The brass is always going to be the live wire, which is always black here in the US, or should always be black here in the US. That is going to go on the brass side, and on the front of the screw you can identify it by this little slot being a little smaller than this side. That's your ground always. That wire is going to go right there on that terminal, just like you see it as I'm illustrating it. Now, the other side is going to be the white wire, which is going to be on the silver screw. This is the white wire that you're going to see coming in from your power supply. It's going to go on here as so. So you're going to have the white wire on the bigger slot, and of course the black wire on the smaller slot, just like you see right there. Now, the next thing you're going to find is you're going to have a ground. You've got to have a ground. You're going to have 3 wires. It's going to be a 10-3 or 10-2, 12-2, but you're going to have 3 wires. The ground wire is always going to go on the green, just like you see right here. Green is ground. It's always going to be the bare wire. That is your grounded wire. Alright, if you look at the back of the switch, you're going to see that there is a little gauge right, let's see if we can find it on this switch. Right here is a strip gauge, they call that. Let me turn it where you can see it. What you do is you lay your wire inside there. You normally want to strip about 3/4 of an inch. You lay that wire inside there, and it tells you how far back that you need to strip that wire for it to be effective in that switch. And if you look at the strip gauge, it's right there. So you'll strip that much wire off of there to get you a good wrap around these screws on both sides. The next thing I want to discuss is if this is a plug and you're only going to be using these 2 terminals, and it's going to be a dead end plug or anything similar to that where you're not going to use these 2 here for power going out. Let me turn it sideways. You'll have power coming in here, you'll have power coming in here. You'll have neutral, you'll have live, and you'll have a ground attached. If you're not going to put anything on these bottom 2 screws, make sure they're cranked in just like you see right here that I'm showing you. You don't want these sticking out there like this to where whenever you push them back in a box, they might touch something else. You might accidentally touch one and get electrocuted. But let me also rephrase, before you work on anything such as this, make sure you have the power supply turned off or the breaker killed. If you don't know where it's at, turn the main breaker off coming into your house. Normally it's going to be around a 200 amp supply breaker at the very top up there. It's the main breaker. So practice safety and make sure you do turn that power off. Electricity will kill you. Do not play with this stuff. Next part of the video is where people fail the most. I've been guilty of it myself, and I have to go back and redo a few things. I know we got some noise in the background, folks. That's AC. It's still 105 degrees here in Texas at the current time we're filming this video. And I'm just too old to put up with that heat. So it's I apologize for background noise, but let's get back to the video. Whenever you use the gauge on the back, this one here has a gauge as well. It is right here. This is your strip gauge. You put that in there and you'll strip that wire back according to the switch you're using or you're purchased or you're installing. And in this case, it'll be this size. Now on this one here, the strip gauge is a little bit different. It's a little longer. So we got to make sure we strip back this wire. This here is actually a Leviton. I believe it is, yeah. No, this is an Eaton standard receptacle. This one over here is an Eaton Heavy Duty Receptacle, and you can see the difference in it, and I'll discuss those in just a few minutes. But we're going to start with the standard one first. This is the one where, like I said, most people really mess up the most. Let me get my black piece of wire. We're going to use a white piece of wire on this side currently. Now this is not where it goes. Remember, white goes on silver. But for demonstration purposes, we're going to put it here. Now you see how that wire sets in there, and it's kind of latched right in there like it should be, all the way around there, and it's sitting close to the screw itself. That's what you want. Also, you don't want this insulation coming back any further than the edge of this receptacle. If you do, you may have some arcing, some sparks, some short going on here, and next thing you know, you got a fire. Throw some breakers, you wonder where the smoke's coming from. That may be your problem. So let's make sure that we always keep this insulation up to it or on top of this blue section right here, never outside of it. Let me see if I've got a piece of wire here. No, I don't. But anyhow, that should have explained it pretty clearly. Make sure that insulation is up on it or right at the edge and nowhere else. What you'll find is some people go in here and tighten these up just like we're doing here, and that is the correct way. I'm going to try to get that closer to the video where you get a better shot of it. That is a nice fitting piece of wire on that screw. The second thing, when you get to this point, take that out. You don't want to come in here and turn this wire this way and hook it the opposite direction. When you do that and you tighten this screw up, what it's going to do, you see the direction I'm turning that screw, which is clockwise, and you get ready to tighten it down, it's going to try to pull this part of it out and run out there a little further once you get to tighten it a little bit tighter. So make sure you flip that loop the other way around. Just like so. The open end's going to be rotating that way. You want the open end on this side at the top. Now we're going to cover the ground wire. Ground wire is always bare copper, and it's going to be on the green screw, or it's going to be the only isolated screw outside of the other two on each side that you're going to have here. It's going to be by itself. That is your grounding screw. This wire goes back to the grounding circuit in the bus bar in the main breaker box. You always want these grounded, and you're going to do the same thing. You're going to put that wire in there just like I showed you there, and you're going to make sure it stays inside this ear here and this ear here. You want that to stay inside this. When you tighten it down, it'll lessen the chances of that thing coming out of there. See, if you do it like that, that's not going to work. So you want to put it down inside that box. If you got to, bend it back a little bit like that right there, and tighten that screw down. I would have liked to have really had that wire further up underneath that screw to make sure it has a really good grounding effect on it. That would work, but I would prefer to put a little tension on the screw of this wire this way and keep it up underneath the head of that screw. That is your grounding part of it. You're going to need to stick around. I got a bonus part of this video coming up at the end that you're going to want to see. You see how some of the problems I'm having with the screwdriver. Well, I'll show you how to eliminate that problem. Now we're going to get back over here to the insulation part on what happens when you don't cut one, strip one the correct way. Now, if we was actually installing this switch, this would be the correct wire going on the brass and not the silver. We're going to install it the correct way, correct direction. But if you look here, let me tighten it down so you can see it. Okay, we got her tight. That's a really good connection. But if you look right here in this area, you're going to see that insulation is up underneath that screw. What you're going to find is that when you tighten that screw down, it's not going to be making 100% contact around the bare wire that you see underneath the screw, because the insulation is a little thicker than that wire, so it's not going to allow you to tighten that down to where it should be, possibly creating a little short in the future and a little bit of electrical feedback underneath there. So that's why it's so important to actually make sure you got this wire stripped back properly, where it comes up to here in this area, and not way out here, and not like I have it there. That's a no-no. Well, now we're on the Eaton Heavy Duty Receptacle. This is my go-to receptacle. I'll pay the extra 50 cents that it cost me to buy this one over this one, simply because it is a far superior receptacle, easier to wire, and lessens the chances of having any kind of electrical problems or shorts. I'm not saying that this Eaton standard plug receptacle is bad. It's good when used the proper way. However, this is where I would go right here. As you see, it looks the same on the front as the other one. It's got a little wider face on it. And the great thing about this is you got 1, 2, 3, 4, 5, 6, 7, 8 places to put wires. So instead of having the 4 that you see on the back of this one here that you can just snap in, and 1, 2, 3, 4 here makes 8 total. It's all in one area here. So it makes wiring up these a breeze. Now, to connect these, you see here I've got this screw here already loose. All you're going to do, this is the same setup as the other plug. Silver is neutral, brass is live, that's black. So we're going to put this one in. All you're going to do is drop it down inside that slot there. You're going to strip it back just like it said on the back of the strip gauge. It's pretty convenient and pretty simple. You're going to run right up here if I can ever get that screwdriver on there. And you're going to snug that baby right down just like so. That is a good fit. You just can't pull it out. It's very, very tight. So if this was being installed in the house, we'd of course have the black wire on this side here on the top 2. One to this plug. And of course this would be powered up because you're bringing voltage in here, and the ground's hooked up over here, of course. So this is going to be live here, and this is going to be live here. Now if you're running to another plug, you're going to of course tie in on these 2 here and these 2 here. Now you won't use both of them, but I guess my point that I'm trying to make is that you can wire in multiple plugs off of this one here because it's heavy duty and it's designed to carry that voltage. That one will go there. I really like this plug. It's a receptacle. It's really a step ahead, way above the standard, and it's well worth the 50 cents more, whatever it might cost to buy this one versus the standard plug. Even at Leviton, it makes no difference. Eaton makes no difference. This is a far superior receptacle as far as I'm concerned. And the other thing I got to mention before I forget it is you don't have to worry about all these wiggly hooks and all this stuff on this plug. It's just a straight strip it down to the desired depth that's needed. Shove it in there. Let's see, where's the open up? Shove it in there and tighten it down. All you got to worry about is that insulation. You'll do that on every one of them that you're going to be installing. Something else about this one, it tells you right here, it's hard to see in the video, but it does tell you that's a ground wire, and it does tell you over here hot wire. So hot wire is your black wire, that is your live wire. It's telling you that it needs to go on this side. So it gives you a little advice there, and of course the neutral is going to be on this side here. And it says CU wire only. So there are basically some instructions right there. If you forget, just look on the back. It'll tell you a little bit of information that you're looking for. Now let's go back to this standard plug for a moment here. I know I covered this briefly, but let's go over it again. There's 4 little holes in the back here. Now if you're coming in with power, black wire here, neutral wire here, and your ground is connected here, you can also go in here and you can take a 14 gauge wire, nothing bigger, because they're not designed for 12 gauge, 10 gauge, but you can take a 14 gauge and you can shove it right down in that hole. Let me find one here. Let's try this one. Strip it back just like the strip gauge says, and you can push it in there. Now I really don't like this technique. I've worked on a few homes and went in there and found that these wires came loose when they was moving this receptacle around in the box, trying to tie the wires into it. It actually pulled loose. It feels snug right now, but once it heats up, sometimes these wires may come loose. So I highly advise not to use what they supplied here on this receptacle. I just don't like it. And to get these out, it does take a little finessing, and it is quite hard. You've got to have something that's flat, and this screwdriver is really a little too big, but let me see if I can demonstrate how it comes out. You're going to have to really push it in there pretty hard, and it takes really 4 hands. But see, once you mash that little lever down inside there, it releases that clamp that was clamped on to that wire. You can see the teeth marks on it. Again, I really don't like that. If you can avoid using that, stay away from it. I've had some issues with that. I've seen it. It's not just some BS story. It just doesn't make a proper bond inside there. Only use it if you have to. Okay, you're at the point you've installed your receptacle and you want to test it. Go down there to Harbor Freight, Lowe's Tools, Home Depot, anywhere where you can find you one of these receptacle testers. This is a south wire. It's a GFCI 120 volts AC plug. Now, I'm going to try to get you a close-up picture here. If you look at the pictures, open ground is the middle orange, and it goes on down to tell you that if it's correct, you're going to have the right 2 light up whenever you plug it into that receptacle. That lets you know if you've got a hot and a ground reversed, or a hot and a neutral reversed, or an open hot, or open neutral, or open ground. If you've got anything outside of these 2 being lit up, you've got a problem. You need to correct it. It means you got to wire across somewhere. So once you get done, plug this into your receptacle after your power is all turned on, and you'll see if you got it correct, these 2 will light up, and you know you've done a good job. If you found any value in this video today, we ask that you go down below and hit the subscribe button, maybe the like button, the bell button, all them buttons down below. You'd be surprised at how much that will help this channel. We need all the help we can get, and whenever you do one of those 3, also leave us a comment below. We respond to all those comments. Comments do help us to figure out what we need to do on our next video, or what we need to change in our next video. Now, hitting that bell icon or subscribe button also helps this video get out there to other people that may be interested in the same topic. Now, we know we're not one of the best YouTube creators out there in this world, but we struggle and we try hard to pass on information that we've gained over the years we've been on this earth. So we ask, hit the subscribe, like button, bell button, and let's get this video out there where other people can see it. We appreciate your time. Thanks for watching. See you in the next video. Alright, now I'm over here by this noisy air conditioner, but you can probably still hear me. And again, I apologize for that AC, but it's just too hot for an old fart like me to work in this office without it. We're over to this receptacle. We got the south wire, and we're fixing to plug this thing in and see what it does. As you see, you got the right 2 lights lighting up. That means that this is a correctly installed plug receptacle. Take a quick moment to check out our other videos to see how we turn this and this into this. As promised, this is a little bonus footage of the video. You can use a flat tip screwdriver on what you're working on. You can use a Phillips head screwdriver on what you're working on. But I'm going to be honest with you, you ain't going to find nothing better than a tool like I'm about to show you for electrical work. This is actually a 12-in-1 Ideal branded. You don't have to buy the Ideal. You can buy any brand you can find, but you want to be really concerned about this particular, you see this pulls out, this particular type of head or bit. I'm not sure you can see it, but I'm going to try to turn it around where you can. You've got, it's like a basically the same design as a Phillips head. However, it's got these wings out here that actually go deeper into. Let's get back to it. You'll sit down in that a whole lot better, and it's a very, very snug fit. You're also able with this tool to get more clamping pressure on that screw to keep that wire a lot tighter than you would with a flat tip or a Phillips head, especially if you've got a no Phillips head here like I'm working on. You see that booger? That old baby kind of slipped off right around the edges there. It's just not that good anymore. So it round that screw out pretty fast, and you wouldn't get the clamping pressure that you really need on that screw. So go on down wherever your store of choice is and find you. They make some 10 in 1, 12 in 1, 11 in 1. I've seen those too. And on the paperwork here, you'll see it. We're using that one and we're using that one, a combo 2 and a combo 1. 9% of the time you're going to use the combo 2, which is a little bit bigger. But guys, that will make your job a whole lot easier and a whole lot simpler. And rest assured, you'll get a nice tight crimp, a nice wire that's clamped in there just like it should be, and you'll sleep better at night knowing you did the job right. Well guys, I hope this video helped you a little bit. Stick around for the conclusion. Oh no, did I just show that? I was trying to test the camera out, see how it worked. I think that's something from Victoria's Secret for the wife. I'm going to put it down.